Good morning. Just sitting here Sunday morning, drinking my coffee and getting ready for some math. All right. So what the plan is I'm going to go back and talk about more of these rational expressions and equations that we started with before all this. So just as a reminder, the word rational means a number that can be expressed as a fraction, right? It's a type of number where something like 1/2 would be considered rational because you express it like a fraction. Even something like the number 3 can be rational because it'd be expressed as 3/1, right? But in this case, we're talking about rational equations or rational expressions. So again, a reminder, if I had something like 2 over x, right, that is a rational expression. But what we're going to be doing now is saying, okay, 2 over x is equal to 3, so solve for x, right? So that's going to be our goal now, is dealing with these rational expressions when they're set equal to something. Okay, so here's the curriculum outcome here, solving problems that involve rational equations. So to solve a rational equation, so what we're going to do is we're going to go over a couple of steps here, and then we're going to take a look at a few examples. And once we've done a couple of examples, we're going to take a look at different types of these questions, and then finally look at some word problems. And I think the word problems here are the most interesting part of this section, because a lot of the times you're setting up equations that are somewhat counterintuitive. So let's just take a look. So to solve a rational equation, the first thing we have to do is bring everything to one side of the equation, right? And that's not just variables, that's everything. What we want to do is take the equation and set it equal to 0. Put all the rational expressions together. So what I mean by that is, let's say I had x plus 2 over x and plus 3 over x plus 1, something like that, right? We know how to deal with an expression like this, or we've seen this so far in the course, right? If I want to add two rational expressions, what I need to do is add them by giving them a common denominator. So this thing is going to turn into something that is x times x plus 1 over, and then we have to adjust our numerators to match. Okay? Set the numerator equal to 0 to solve for x. Once we have this thing as one big fraction, and it's already set to 0, the only way to get a fraction that's equal 0 is for the numerator to be 0. So what we want to do is just say, okay, when will the numerator be 0? That's all I care about. Because when the denominator is 0, that's when we're going to have our non-permissible values, right? So the only thing we care about is saying, okay, when will the numerator be 0? Once we have an answer, we have to go back to make sure our answers are not some kind of restrictions. Because again, with this idea of fractions, there are rules to fractions. We can't have a denominator of 0. So if one of our answers gives us a denominator of 0, we have to make sure that we're checking that. So let's take a look. Here's a question here. Example number 1, solve the following equation. What values are non-permissible? So what we want to do here is solve this equation for z, and then figure out which values will be non-permissible. Okay, so step 1, again, what we're going to want to do is take everything and put it on the same side of my equation. So we're going to take this, we're going to say 2 over z squared minus 4 plus 10 over 6z plus 12. Now, to move this thing over, this whole fraction here is just one term, right? It's not the individual pieces of the term that we're moving, it's this whole fraction. So to move something from one side to the other, we're going to take its negative. So we're going to subtract 1 over z minus 2, and that will be equal to 0. Okay? Now that we have our equations with everything on one side and equaling 0, we want to add. Well, how do we add fractions? We have to add them by finding a common denominator. Now, to find a common denominator, our first step is to factor everything, right? So 2 over z squared minus 4 is z plus 2, right? Z minus 2. And again, a lot of these units are going to come back to factoring. So it's really an important skill to have, right? We have to be trying to factor these things, or we have to know how to factor these things. And if we don't, it is something that needs to get practiced. All right, so our denominator here has a common factor of 6. So we're going to factor that out and be left with z plus 2 and minus 1 over z minus 2. And this thing is equal to 0. All right, so now what we start to recognize is that our common denominator, there's a z plus 2 here and a z plus 2 there. There's a z minus 2 here and a z minus 2 there. Also, notice that this 10 and a 6 have a common factor that can be factored out. They can both be divided by 2, so this 10 turns into a 5, and this 6 turns into a 3. Now, let's add everything together. Now I know my common denominator. On the bottom, there's a 3, a z plus 2, and a z minus 2. Okay, so in my numerator now, what's left? Well, this 2 here needs to get multiplied by 3 because the bottom needs, the only thing that this denominator here is missing is a 3 from this group of factors down here. So let's take the 2 and multiply it by 3. Right? 2 times 3. Plus, this one already has the 3. It already has the z plus 2. So the 5 is going to have to get multiplied by z minus 2. Minus, and the 1 already has the z minus 2, but it doesn't have the 3, and it doesn't have the z plus 2. Okay, so at this point, you might want to take a second to state your non-permissible values, right? If we take a look at our denominator here, what values for z would make this equal 0? And it comes from this bracket here and this bracket there, so now we know z cannot be 2 or negative 2, right? Those are our non-permissible values. So now, once I've used my denominator to say, well, those are my non-permissible values, at this point, it's not that my denominator goes away, it's that it doesn't make a difference to the answer of our question. The only thing that's going to take this fraction and make it equal to 0 is the numerator. So the denominator doesn't really matter in that case. So with that in mind, what we're going to do is we're going to take this fraction and we're just going to focus in on the numerator for a second. So 2 times 3 is 6. If I expand this bracket, 5 times z is 5z, and 5 times negative 2 is negative 10, minus, and I'm going to put a bracket around this whole expression because everything we get from here has to get subtracted. So 1 times 3 times z is 3z, and 1 times 3 times 2 is 6. And this thing is going to be equal to 0, right? Again, the denominator didn't go away. It's not like it just for no reason went away. We just don't really care about it. We're not going to focus on it for a second. We're just going to take a look at the numerator and say, okay, when will the numerator be 0? So that's what I'm solving for now. So now it's just a matter of combining all of my like terms. So here I've got a positive 5z and a negative 3z, so I'm left with 2z. And here I have a positive 6, a negative 10, and a negative 6. So that's minus 10. And this thing will be equal to 0. So now if I solve for z, I get 2z is equal to 10. So then z is equal to 5. And again, my non-permissible values were that z is not allowed to be 2 and negative 2. So at this point, what we should do with that 5 is we should check. We should check to make sure that the 5 will actually work and that it's not going to give us something that doesn't work, right? So we're going to take that 5 and we're going to plug it in here for z. We're going to say 2 over 5 squared minus 4 plus 10 over 6 times 5 plus 12 is equal to 1 over 5 minus 2. All right, so now we're just going to go through, take it one step at a time. So 2 over 25 minus 4 plus 10 over 30 plus 12 is equal to 1 over 5 minus 2 is 3. All right, and then just kind of slowly work my way through it. So 2 over 25 minus 4 is 21 plus 10 over 42 is equal to 1 over 3. So this is 2 over 21 plus, there's a common factor here of 2. So if we divide the 10 by 2, we get 5. And if we divide the 42 by 2, we get 21. Right? 2 plus 5 is 7 over 21. And 7 over 21 is 1/3. So 1/3 is in fact equal to 1/3. So now what we can be certain of is that our z equaling 5 is in fact the answer because we've checked and it gets us the same number on both sides. Alright, so again, just like with previous videos, what I'd like you to do is pause it, try this question, get to an answer. Once you think you have an answer that works, start the video back up and then check your work against mine. So, same 4 steps or 5 steps as last time, right? First thing we're going to do is we're going to take this equation and we're going to get everything to the same side. So we get 9 over y minus 3 minus 4 over y minus 6 minus 18 over y squared minus 9y plus 18. And this is going to be equal to 0, right? And this is the big difference between equations and expressions, right? That equal symbol, right? Once you see that equal symbol, now we know y is going to have an answer. So now to get this over a common denominator, right, we have to factor everything to make sure that we can find our common denominator. So y minus 3 is just going to stay y minus 3, right? Y minus 6 is just going to stay y minus 6. But this quadratic can be factored, and surprise, surprise, it is y minus 3, y minus 6, right? Just to simplify our lives a little bit, the two factors here are the same as the two factors there. So now my common denominator here is going to be y minus 3, y minus 6, where this one already has the y minus 3, so the 9 needs to get multiplied by the one that's missing, the y minus 6, minus the 4 over y minus 6 already has the y minus 6, so the 4 needs to get multiplied by the y minus 3. And this one already has both, so it's just going to stay 18. So again, at this point, what we probably want to state is that our non-permissible values, y cannot be 3 because of the first bracket, and y cannot be 6 because of the second bracket there. Once we have our non-permissible values, again, what we're going to want to do is just focus in on that numerator. Say, when will this thing be 0? Because when this thing is 0 is when our answer is going to be 0. So we're going to just take a look at the numerator by itself. So 9 times y minus 6 minus 4 times y minus 3 minus 18. When will this thing be 0? Expand all your brackets and then solve for y. So here we get 9y minus 54 minus 4y plus 12, right? This is a negative 4 and a negative 3, so when you multiply them, you get positive 12. And then minus 18 is equal to 0. Combine all your y's, combine all your numbers, so we have a positive 9y and a negative 4y leaves us with positive 5y. Negative 54, positive 12 is negative 42, and negative 42 plus 18 is, or sorry, minus 18 is negative 60. So then we're left with y equals 12. Well, sorry, I kind of skipped a step there. 5y is equal to 60. And then we divide both sides by 5, we get y is equal to 12. So again, there's my possible answer for this rational equation. And up here were my non-permissible values, right? Let's undo that. Actually, there we go. Do that again. Okay, so now what we're going to want to do is check our work. Let's make sure that y equals 12 is in fact a solution to this equation. So 9 over 12 minus 3 minus 4 over 12 minus 6 is equal to 18 over 12 squared minus 9 times 12 plus 18. So we get 9 over 12 minus 3 is 9, right? 4 over 12 minus 6 is 6. And 18 over 144 minus 108 plus 18. So 9 over 9 is 1. 4 over 6 is 2/3. And this is 18 over 144 minus 108 is 36. And 36 plus 18 is 54. All right, 1/3 minus 2/3 is, 1, which is 3 over 3, minus 2 over 3 leaves us with 1 over 3. And 18 and 54 have a common factor. 18 is 18 times 1, and 54 is 18 times 3. So if I cancel out the 18s from both, I'm left with 1 over 3. So what we're pretty confident about is that our answer was correct, that y equals 12. Okay? So sometimes we do these questions, we're actually going to find that we're going to get multiple answers, or even if we just get one answer, what we're going to find is that answer doesn't work. And we'll see here with this example. So we're going to do exactly the same steps as before. We're going to get everything to one side. We're going to isolate that numerator so that it's equal to 0. We're going to get our non-permissible values. Right, we're going to do all that stuff as before. So again, same steps. 4k minus 1 over k plus 2 minus k plus 1 over k minus 2 minus k squared minus 4k plus 24 over k squared minus 4. And this is equal to 0. And again, what you'll find here is that your denominators are going to have really similar factors, right? So if we factor everything, so for k minus 1 over k plus 2 minus k plus 1 over k minus 2 minus, so let's see if we can factor the top and the bottom here. So the top, is that factorable? Two numbers that multiply to give me 24 but add to give me -4. No, so that's not factorable, so we're just going to leave that as k squared minus 4k plus 24. Now the bottom, though, k plus 2 and k minus 2. And that's equal to 0. Right, so again, we're going to write out our common denominator here is k plus 2 and k minus 2. And then, again, whatever this denominator is missing, we have to multiply to the numerator. Right, so the k plus 2 is already here, but it's missing the k minus 2. So this 4k minus 1 needs to get multiplied by k minus 2 minus, right, this k plus 1 here, this k minus 2 here is missing the k plus 2, so k plus 1 has to get multiplied by k plus 2. And again, minus, this one already has both, so it's just going to stay as is. K squared minus 4k plus 24. And this thing is equal to 0. So again, at this point, what we're going to want to do is state our non-permissible values, just to say that, yeah, this thing has values of k it's not allowed to be. And we get that from our denominator, right? This thing, k, is not allowed to be -2, and it's not allowed to be +2. All right, so now we're going to focus in on the numerator. We're going to say, okay, well now, when does 4k minus 1 times k minus 2 minus k plus 1 times k plus 2 minus k squared minus 4k plus 24, right? When does this thing equal 0? Yep, so now we're going to expand all of our brackets and then combine like terms. So for each pair of brackets here, we're going to use FOIL, right? We're going to say 4k times k is 4k squared. 4k times negative 2 is negative 8k. Negative 1 times k is negative k. Negative 1 times negative 2 is positive 2. Right, there's this bracket right there. Minus, we're going to do the same thing for this bracket. So k squared plus 2k plus k plus 2. You'll notice I put that bracket or this answer in brackets. Again, because of this negative symbol here, it has to apply to everything we get. And then minus k squared minus 4k plus 24 is equal to 0. Right, so now at this point, we're going to combine all of our like terms. So here I have a positive 4k squared, a negative k squared, and a negative k squared leaves me with 2 k squareds. Negative 8k and negative 1k is negative 9k. Negative 2k gives me negative 11. Negative 1 more is negative 12. And this ends up being positive 4, so we get negative 8k. And here we have positive 2, minus 2 is 0, minus 24 is negative 24. Okay, so now it's just a matter of solving for k by factoring, right? So both, all three terms have a common factor of 2, so we can take the 2 out, 2 onto k squared minus 8k minus, oh, sorry, that's not 8, minus 4k minus 12. And now we're looking for two numbers that multiply to give me negative 12, but add to give me negative 4. And that would be k minus 6 and k plus 2. So from here, what we can say is that our answers are k is equal to 6. And from this bracket, we get k is equal to negative 2. So right away, it looks like we have two answers. But if we stop and think about this for a second, do both of these answers work? And right off the bat, you should recognize one of these answers as being like, hey, wait a second, we know that one doesn't work, right? If we think back for a second, we already stated that our non-permissible values, the values that k is not allowed to be, are negative 2 and positive 2, because those numbers are what make the denominator 0, which means that k minus 2 cannot be an answer. And if we did use k minus 2, what we would find is that if we plugged it into the original equation, what we would get was we would get 0 over 0. And again, in math, even if the numerator is 0, the denominator is still not allowed to be 0. So this is a big no-no. Right? But if we did the k equals 6, and we plug that back into our original equation, what we'd find is that it would just give us the 0 in our numerator, which we're looking for, over some number, right? That we don't really know what that number is going to be. So again, give this a try for me. Pause the video. Once you've had a chance to try this question, turn the video back on and take a look at the answer and compare it back to your own. Okay? So here we go. Move everything to one side. 3x over x plus 2 minus 5 over x minus 3. Oh, come on. There we go. Now, this negative here could be moved here. Just say that this is the negative of that bracket. So when we bring it over to the other side, it's actually going to become positive 25 over x squared minus x minus 6. And that's equal to 0. Now, take a wild guess what the factors of this one are going to be. I mean, if you've seen the pattern so far, the questions are purposely not giving you more than two factors. So you can probably guess that it's going to be x minus 3 and x plus 2. But let's check, right? X plus 2 minus 5 over x minus 3 plus 25. Two numbers that multiply to give you negative 6, but add to give you negative 1, and we get x plus 2, x minus 3. Right, so right there, there's our common denominator, right? X plus 2 x minus 3. So again, we're going to go through and see what everything's missing. So the 3x, right, that's missing the x minus 3, minus the 5 is missing the x plus 2, and the 25 isn't missing anything, so it's just going to stay 25. Right, now from here we can say, okay, well I know now that x is not allowed to be negative 2 and is not allowed to be positive 3. So let's go through and solve for x by looking at just the numerator. So 3x times x is 3x squared, and 3x times negative 3 is negative 9x. The negative is going to stay there for a second. 5 times x is 5x, and 5 times 2 is 10. And then plus 25 equals 0. So now let's combine all of our like terms. So 3x squared, negative 9x, negative 5x is negative 14x. And negative 10 plus 25 is 15. Okay, so now to factor this thing, we could use slide and divide. Right, so we take the 3, slide it to the end, we get x squared minus 14x plus 45 is equal to 0. This thing can be factored by x minus 5 and x minus 9. There, now we have to do the divide part of slide and divide. So this turns into 3x minus 5 and x minus 3. So we get an answer of x is equal to 5 over 3, and x is equal to 3. And again, if we look at our non-permissible values, we've already decided that x equals 3 is a non-permissible value, right? It's not allowed. So if that's the case, we can say that this answer, the x equals 3, is not allowed. And what we get is that x equals 5 over 3. Okay, so this, as I was saying earlier, is probably the most interesting part of these rational equations, the word problems, because they're not really intuitive. It's actually kind of a weird type of question, one that the answer doesn't like stand out as being very obvious. And we'll take a look at why that is right here. So here's my first example. 2 friends share a paper route. Sheena can deliver papers in 40 minutes, and Jeff can cover the same route in 50 minutes. How long to the nearest minute does the paper route take if they work together? Now, there's a lot of answers people like initially kind of come to here. And one of the first ones people kind of think, well, it's 45, right? Right? That's the first answer people assume when they look at a question like this. It's because like they haven't really seen anything like this before. And the way we get 45 is like, well, if it takes her 40, if it takes Sheena 40, and it takes Jeff 50, so if we go somewhere in between, that's 45, right? But as soon as you kind of do that, just stop and think about that for a second. If it takes Sheena 40 minutes to do the paper route, by adding Jeff's help, how can her time get to be more, right? So it doesn't really make sense. It's just an answer that people kind of initially jump to right away. So let's take a look at how we would do something like this. And what I suggest is when you're presented with a question like this, make a table. Make this table where you have this information kind of separated and divided into a really visible manner, right? So what we're going to want to say is, okay, well, first off, how long does it take each of these people to deliver papers, right? So we know Sheena takes 40 minutes. We know Jeff takes 50 minutes. And this bottom part here, the together, well, that's what we're trying to solve for. So let's leave that as some variable. You could use x, you could use k. I use t here to stand for time. It does not really matter, just some variable. Then once we know that, what we're going to want to do is we're going to want to take this information and look at it in a unit, meaning as just an increment of 1. So for example, here we're talking about minutes, right? We're talking about how many minutes it takes them to do the route. So instead of separating this information in minutes, let's see what fraction of the route each of these people can do in 1 minute. So if it takes Sheena 40 minutes to do the paper route, in 1 minute, she does 1/40th of the route. Jeff takes 50 minutes, so in 1 minute he'll do 1/50th of the route. And together it takes them t minutes. So if we kind of follow that pattern of 1 over 40 and 1 over 50, so together it's going to take them 1 over t. Now, if we look at the amount of time that it takes them to do together, so if Sheena can do 1/40th the route in 1 minute, then she can do t over 40 of the route in t minutes by taking the 1 over 40 and multiplying it by the time they spend doing the route, which is this variable t, right? So if we take that 1 over 40 and we multiply it by t, we get t over 40, right? And then if we do the same thing for Jeff, we get t over 50. So what that means is that however much time it takes them to do the route together, Sheena will do a 40th of it, and for every 50th that Jeff does, right? So if we take these two numbers and we add them together, so this is the amount of the route that Sheena does in t minutes, and this is the amount of route that Jeff does in t minutes. So if we add these two fractions together, what we should get is 1 whole paper route, right? So now that we have these fractions, we can make an equation and solve for t. So what we can say is that, well, if Sheena does this much of the route and Jeff does this much of the route, then together they should get 1 whole paper route done. And at this point, all we need to do is solve for t. Right? So again, what we might want to do here is find a common denominator. So common denominator here would be 200. All right, so this is going to be 5t plus 4t equals 1. Okay, now it's just a matter of solving for t. And the nice thing here is what we can do is we can multiply both sides by 200, right? Because this 200 will cancel out with this 200. And then over here, we'll get 200 times 1, which is 200. So 5t plus 4t equals 200. T is equal to 200, so then t is equal to 200 over 9 minutes. Or for those of you that are decimally inclined, right, 200 divided by 9 is 22.2 repeating minutes. Okay, so like I said, these questions are not intuitive, and I know right away a lot of you are gonna look at this and just be like, what? It's gonna take some extra work. What I highly recommend is I'm gonna leave you guys with some textbook questions. Give them a try. I'm gonna leave an assignment just like I did with the previous section up on Teams. Give that a try. Come to the live session on Thursday. And ask questions, right? Because it is not intuitive unless you practice, okay? So give it a try yourself, right? Pause the video, try this question. Then once you think you have an answer that makes sense, start it back up and we'll go over it together. Okay, so let's take a look at this question here. All right, so again, what we're going to want to do first is make a table. Right, make a table to organize our information. So in my table, I'm going to have 3 sections. So Stella takes 4 hours to paint her room. Okay, Josh takes 3 hours to paint the same area. And we want to know how long it'll take them to do it together, right? So give me a second here. I'm still trying to make my table. So the first one, the first column, what we're going to talk about is the different people or the different criteria, right? So here we have Stella. Here I have Josh, and then the question wants to know how long will it take them to do the room together. So really similar to that last question where we have two people doing the same task in different amounts of times, and then let's see how long it takes those two people to do the task together, right? So again, what we should find is that when they do it together, the task should get done quicker, right? So time to paint the room, right? That's going to be in our first column. So for Stella, it takes 4 hours to paint the room. Sorry, not Josh. For Jose, my goodness, it takes 3 hours to paint the room, right? And the units here are hours. So together, it's going to take them T hours. Then in the second column, we're going to want to know, well, how much of the room can they paint in 1 hour? Well, Stella can paint a quarter of the room, right? If it takes her 4 hours to paint a whole room, it's going to take her a quarter of an hour to paint. Sorry, she can paint a quarter of the room in 1 hour. For Jose, it's going to be a third of the room, and then together they can paint 1/10 of a room, right? So if it takes them T hours to paint the room together, then they're going to be able to paint 1/T of the room in 1 hour. And then finally, if we take a look, so how much of the room does Stella paint in T minutes? Or T hours, sorry. Room painted in T hours, right? So Stella is going to be able to paint a quarter of the room in an hour. So if we're looking at T hours, we're going to take a quarter and multiply it by T, and we get T/4. Jose can paint a third of the room in 1 hour. So if we take 1/3 and we multiply it by T, we get T/3. And then for both of them working together, we know that they can paint the whole room in T hours. So if we take the 1/T and we multiply it by T hours, that means they've painted one whole room. Okay, so at this point, let's solve for T. Because if I take these two fractions here and I add them together, so T/4, and that's the amount of the room that Stella can paint in T hours, and T/3 is the amount of the room Jose can paint in T hours, that should be equal to 1. So now let's solve for T. Right, so again, I could find a common denominator here, which would be 12. Multiply both sides by 12 to get the T's by themselves, so I'm left with 3T plus 4T is equal to 12. 7T is equal to 12, so T is 12/7 hours, or 1 hour and 5/7 of an hour, right? Or 5 divided by 7 times 60, 1 hour, approximately 1 hour and 43 minutes. Okay. So like I said, these questions, they can be somewhat counterintuitive, so it takes practice. It definitely takes a lot of practice to do these questions, to get them right. So I would suggest trying all of the work for this week, right? Trying the textbook questions, trying the assignment questions, and making sure that you understand the content as best as you're able to. Okay? Okay, example number 4. Lots of information going on here, right? The Northern Manitoba Trappers Festival, held in the past, originated in 1916. A championship dog race has always been a significant part of the festivities. In the early days, the race was non-stop from the pass to Flin Flon and back. Now, again, when I'm looking at word problems, right, I don't care about that. It's not that I don't care. I mean, it gives context to the problem. But in terms of actually doing the work, this information here does not give us anything that's going to be useful to solving the question. It just gives us some kind of preamble about what the question is asking us to do, right? More this part down here. So in one particular race, the total distance was 140 miles, right? So right there, we're starting to get some information that really matters, right? So the total distance was 140 miles. right? Conditions were excellent on the way to Flin Flon. However, bad weather caused the winner's average speed to decrease by 5 miles per hour. So the average speed on, however, bad weather on the way back, right? So the conditions were good on the way there, but on the way back, right, on the return trip, he was 6 miles per hour slower. And the total time for the trip, so total time was 8.5 hours. So now what it wants to know is what was the total average speed on the way to Flin Flon. So the speed on the way there, right? So if we're going to pick a variable like x or k or s or whatever it is, right? The thing we're trying to set the variable is speed on the way there. So then the speed on the way back is going to be that number minus 6, right? So keep that in mind when we're organizing our table. Another thing to keep in mind here is for those of you that have taken physics before, right? You might have seen a triangle like this where time is distance over speed, speed is distance over time, and distance is time multiplied by speed, right? So keep those formulas in mind when we're filling in our table, okay? So here's my table. Maybe. Here's my table, right? So we have our categories here, right? We have our trip there, and we have our trip back. And we have our distance, we have our speed, right? Rate is another word for speed, and we have the time that it takes. So what do we know? Well, we know the distance, right? We're being told that the total distance was 140 miles. So that's fine, right? 70 there, 70 back. The distance isn't going to change. The distance is not going to depend on the weather. It's not going to depend on how fast we are going. It's always going to be 70 miles. Now the speed. This is what we're being asked to find. What was the winning dog's average speed on the way there? So that is the thing that we're going to set equal to x, right? We're going to say, well, this is what we're trying to solve for, so let's let that be x. And we know that the speed they were moving on the way back is 6 less than that. So x and x minus 6. Now, time. We know the total time, right? We know what the total time is. We know the total time is supposed to be 8.5 hours, but we don't know how long it took to get to Flin Flon, and we don't know how long it took to get back. So what we can do with this information is we can set up the equation. Time is equal to distance over speed, or time is equal to 70 over x to get there, and 70 over x minus 6 to get back. Now, the total time it took to run the race is going to be equal to the time it takes to get there plus the time it takes to get back. And that should be equal to 8.5 because that's the total time. It already told us that, right? So now what we're going to want to do is solve for x, right? So now we know that if we take the time it takes to get there and we add it to the time it takes to get back, we'll be left with the total time of our race, right? 17 over 2. Now notice here I took 8.5 and we turned it into 17 over 2 because it's easier to work with these improper fractions, right? So now common denominator, so 70 times x minus 6 plus 70x all over x times x minus 6, right? And this thing is going to be equal to 17 over 2. Now, at this point, you might notice that I didn't do the steps from previously. You could have moved the 17 over 2 over, found a common denominator for everything. But when we have this thing here that's not a rational expression, it's just a rational number, it's just a number by itself, I'm going to leave this here for a second. And the reason I'm going to leave this here for a second is now that I've done this, now that I have one fraction on the left side and one fraction on the right side, what I can do to kind of simplify my life a little is to take this denominator here and multiply it up to that numerator, and then take this denominator here and multiply it up to that numerator. So when I do that, I get 2 times 70 onto x minus 6 plus 70x. And I get 17 onto x times x minus 6. Right? So now I'm going to have a big series of polynomials, but no more rational polynomials, no more of those fractions, right? So now let's just expand everything and then start getting x by itself. So if I take the inside here, so I'll leave the 2 for a second, 70 times x is 70x, and 70 times negative 6 is negative 420 plus 70x. Leave the 17 alone for a second. X times x is x squared, and x times 6 is negative 6x. Okay. Now I can add the inside, multiply the 2, so 70x plus 70x is 140. 140 times 2 is 280x. 420 times 2 is 840. 17 times x squared is 17x squared, and 17 times negative 6x is 102x. Let's see, 10 times 6 is 60, 7 times 6 is 42, 60 plus 42, yeah. All right, and then if I move everything to the same side, so 0 is going to be equal to 17x squared minus 102 plus 280 is 382x plus 840. So at this point, it's a little ugly, but let's see if things clean up a little bit here. No, so now I would probably use my quadratic formula in order to solve for x, right? So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, so start simplifying this a little bit. So the negative of negative 382 is positive 382 plus or minus the square root of 382 squared minus 4 times 17 times 840 is 88804 all over 34. Which, if I take the square root of 88,804, I get 298 over 34. Okay, so then what that means is 382 plus 298 divided by 34 gives me x equals 20. And 382 minus 298 divided by 34 is x equals 2.47, right? So again, the units here were miles per hour, right? Because we're looking for speed, we're being told that our speed is in miles per hour. So x here is either 20 miles per hour or 2.47 miles per hour. Now, right away, you probably look at this and thinking, well, how do I have two possible answers? And if I'm not supposed to have two possible answers, which one is right? And this is why with word problems, we really have to think about the context of the question, right? X equals 20 and x equals 2.47. Which of these two answers actually make sense? You're probably leaning towards one more so than the other, and I'll tell you right now, the right answer here is this one. Now, why, I guess, is the question. Why is it that one? Why is it not the 2.47? Well, think about the question, and let's reread it for a second. Or let's even look at our table for a second, right? Now that I know my answer is either 20 or it's 2.47, right? That's this x here, the speed that we're going on the trip there. Then if we look at the speed we're going on the way back, well, 20 minus 6 is 14, but 2.47 minus 6 is negative 3.53. And it's this number right here that bothers me, right? What does it mean to have negative speed? And you can't have negative speed, right? When we're talking about units, right, velocity can be negative because that means direction. But in this case, I don't want a negative speed. I want a positive speed. So if I'm looking at which of these two answers make sense in the context of this question, if I know they went 6 miles per hour slower on the way back, then this number here can't be less than 6, right? It can't even be 6 because how could they be moving at 0? They'd never get back, right? So the only answer that makes sense in the context of this question is the 20. Okay, so one more of these questions. Again, pause the video, read the question, give it a try. Once you're ready, we'll start back up and check your answers. If you want to jump right to the textbook questions, here's a couple right here that are pretty good to try. So I will, give you guys a second to try this, and then we'll do it together. So a train is scheduled to run 160 kilometers between two cities in Saskatchewan. If the average speed is decreased by 16 kilometers per hour, the run will take a half hour longer. What is the average speed of the train? So again, we're taking a look at our city one, sorry, not our city one, the route to go from city one to city two, right? So we have two cities in Saskatchewan that this train is traveling between, right? We have an average speed that we're not aware of or we're not sure of, but what we know is that the speed is, when it gets decreased, it'll have this impact 1/2 hour longer on the time it takes to get there, right? So we have the information when we're talking about speed 1, and we have a different set of information we're talking about speed 2, right? We know that we're looking for distance, rate, and time. So when we're talking about speed 1, what's our distance between the two cities? 160 kilometers, right? It doesn't matter which speed or how fast we're going. The two cities are still going to be 160 kilometers apart. Now, we're trying to find the rate of the train. So that is the thing that we're going to say is, okay, this is X. Okay? Now, we don't know what the we don't know what the speed is yet, but we can solve for it. Now, what we do know is that the rate, the second rate, is X minus 16. Now, again, the time, we don't know what the time is, but what we do know is that we can calculate time by saying distance over speed. So if I have 160 over X, that will give me the time it takes to get from one city to the next using this speed. And if I have 160 over X minus 16, that'll tell me the time it takes using the second speed. Now, what is this question asking us to do? Because with the last question, it wanted us to find the total, right? It wanted us to say, well, the total time was 8.5. But with this question, it's not looking for a total. It's telling us that the change in time will be 1/2. So now I'm not asking you to add them together. I'm asking you to find the difference of the two, right? One of them is going to be a half hour slower. So instead of finding the total, the difference in the two times is going to be 1/2. Now, which one is more and which one is less? Because we want to make sure that we're subtracting them in a way that's going to give us a positive 1/2. And the answer to that question is the slower speed is going to take more time. So this one here, the X minus 16, it's going 16 kilometers per hour slower, so it is going to take more time. So when we go to subtract these two numbers, we're going to take the 160 over X minus 16, and from that, we're going to subtract 160 over X, and this should be equal to 1/2. Okay, so now we're going to solve for X the same way we did with the previous question. So over here, I'm going to find a common denominator. So 160 multiplied by X minus 160 multiplied by X minus 16 all over, that's a line, all over X minus 16 times X. and this is going to be equal to 1/2. And again, what we can do with this question is we can get rid of the fractions by multiplying the denominator on one side to the numerator from the other. So I can take this 2 and multiply it by the entire left-hand side. So 160 times x minus 160 times x minus 16 is equal to 1 times x minus 16 multiplied by x. Right, so now if I take everything and I expand it, and then we get all of our x's, everything to one side. So 160 times x is 160x, and 160x times 2 is 320x, minus 160 times x times 2 is 320x. 160 times 16 is 2560 times 2, right? So this is minus, and a minus gives me positive 5,120 is equal to x times x is x squared, and negative 16 times x is negative 16x. Right, so now if I move everything from one side to the other, I'm left with 0 is equal to x squared minus 16x minus 5,120. Right, so now this thing could possibly be factored. We could use the quadratic formula. If I wanted to figure out if this thing could be factored, I'd start looking at the factors of 5,120. So I'd say that that's 5,120 and 1. And because it's negative, that means one of them is going to be positive, the other one's going to have to be negative. And we're looking for negative 16, so the difference between the two. So this one would be 2 and 2560. 4 and 1280, right? 5 and 1024, right? And we're just going to kind of slowly figure out our factors that are going to have a difference of 16, right? And just keep working my way down. So 1280 divided by 2 is 640 and 8, which is 320 and 16, which is 160 and 32, which is 80 and 64. And right there, the difference of these two factors is 16. So now I know that this is x minus 80 and x plus 64. So my answer now is x is either equal to 80 or x is equal to negative 64. But again, in the context of the question, negative 64 doesn't make sense. And in fact, if you were to take negative 64 and try to figure it out, what that's telling us is that the speed there is going backwards 64. And this, if I took 64, negative 64, and I subtracted 16, I get negative 80. So I still get 80 and 64. It's just looking at the question in reverse, right? So going 80 kilometers an hour this way is similar to going 16 that way, 64 that way, right? So what this is telling us is that we get the same numbers either way. But the one that makes the most sense in the context of this question is the positive one, the positive 80 kilometers per hour. Okay, so again, there's some textbook questions. The textbook, the PDF is in the Microsoft Teams, so that's available for you guys to give those a try. What I'll do is I'll post an assignment to go along with this video. Give it a try for me. Come to class Thursday with questions. And what I'll do is I'm going to post a quiz at the end of the week, probably on Friday. I want you guys to try the quiz. And I'm going to put a time on it. I'm going to make it sometime probably in the afternoon Friday. But don't feel like you have to do it exactly that time. It'll be available at that time. I'm gonna give it an end time, but I'm going to make it optional for you guys to submit it late. So if you take an extra bit of time, don't worry about it, right? If you can't be there during that time, or if you have other work to do, that's fine. Just at some point in time, between Friday, Saturday, before I submit any new videos on Sunday, give that quiz a try and submit it through Teams. Yep, that is it for today. We only have the one video this week, right? So not too much to do. Watch this video, try the questions, and then I will hopefully see you guys Thursday. All right.